In this video, we are going to be discussing example 2.8 uh, of solutions. I think I should have mentioned the fact that we're talking about solutions. So 2.8 of solutions. The boiling point of benzene is 353.23 Kelvin. When 1.80 grams of a non-volatile solute was dissolved in 90 grams of benzene, the boiling point is raised to 354.11 Kelvin. Calculate So we need to calculate the molar mass of the solute Kb of the solute. Kb of benzene is 2.53 into 2.53 Kelvin kilogram per mole. So first of all, let's write down whatever we've been given. And this is just going to be using the equation of calculation of the molar mass using the elevation in boiling point. So we've been given the boiling point of benzene. So that I'll just call it TB naught is equal to 353.23 Kelvin. The next one, uh, okay, let's have the boiling points on this side and the masses on this side. So we've been given the mass of the non-volatile solute. So W2 equals to 1.80 grams. Then W1 will be equal to 90 grams of, because we've been given the mass of the solvent, that is W1. The boiling point is raised to 354. So the TB, the value of TB, that is going to be 354.1 Kelvin. Let me erase it. Okay, 11 Kelvin. So this is the value of the boiling point of the solution itself. Now we need to calculate the molar mass of the solute. So we need to know the value of M2 is equal to how much, and we have the value of Kb for benzene, which is 2.53 Kelvin kilograms per mole, and we know the value of the molar mass of benzene, that is M1, will be equal to, actually wait, this is for temperature, right? Never mind. You actually do not need the molar mass of your solvent. Okay, so we will be basically using the equation M2, which is the molar mass of the solute, is equal to W2 into Kb into 1000. Okay, this is because we want to convert our kilograms to grams, and molality is going to be in kilograms. Because of that, we're using that whole divided by delta TB into W1. So let's start with calculating the value of delta TB. So delta TB is equal to the boiling point. Delta TB equals to the boiling point of the solution minus the boiling point of the pure solvent. So TB, which is 354.11 Kelvin minus 353.23 Kelvin. So this gives us 0.88 Kelvin. So this is the value of delta TB. Now all we have to do is substitute all of these values in the equation. So W2, which is 1.80 grams, Kb is 2.53 Kelvin kilograms per mole, and then 1000. Remember that 1 tiny topic where in class 11 where you talk about conversion of units. So basically for us to convert something from kilograms to grams, we will have to base which is going to be using that. There is a video in this channel where I talk about that, so feel free to check that out. That's where this grams per kilogram comes from. And whole divided by delta TB, which is 0.88 Kelvin. Oh no, I hope my computer does not die right now. Into 90 grams. Okay, as always, we start with the units. So gram and gram gets cancelled. Kelvin and Kelvin gets cancelled. Kilogram and kilogram inverse like gets cancelled. So we are left with grams per mole, which is exactly what we want. So we start with simplifying these things. So you get, when you multiply these two values, we are getting 4.554 into 1000 excuse me, grams per mole divided by, when you multiply these two values, you get 79.2. And this, on further simplification, is going to give us, this divided by this is going to give us 0.0575 into 1000 grams per mole. And this further gives us 57.5 grams per mole. Basically, we calculated the value of delta TB and we just substituted all of these values into the equation. That's all we did. And we used the equation related to the elevation in boiling point and calculating the molar mass of the solute using the elevation in boiling point. Do let me know if you find such videos helpful. Do also let me know if you like this over using a whiteboard. That in turn helps me understand what kind of content you're looking for. And with that, we're done with this video. In the next video, we will be continuing with the example problems.